or depreciation, okay? Now, what the heck did the values of the formula, you aren't given any of these formulas, just so you know, you have to memorize them. If you're given them on the diploma on a question, it's a bonus, but I wouldn't assume you are. So if it's an appreciation or a depreciation, I kind of set them all up the same, so they're very similar, the different formulas. But F represents final amount. Capital I represents initial amount. The little I represents interest in decimal form. So if it's 88%, you'd use 0.88 because there's no percent symbol. And N is the number of years. Now to explain the formulas, we have 1 plus I and 1 minus I. If it's appreciating, it's growing. I do 1 plus I. Now I told you I is interest rate in decimal form, correct? So like if it was 88%, it would be 0.88. So I'm doing 1 plus the decimal interest rate. Well, what does 1 represent in interest rate form as a decimal? 100%. So if I take 100% of something, it's not depreciating and it's not appreciating. If I take 100% of something, I just have that value, correct? So 100% is neither growing nor decaying. 100% is just, I have 100% of it, here it is, right? I walk up and I take my population of butterflies and I have 100% of them and here they are. Now, if something happens that's killing off the butterflies, they're depreciating, so I'm going 100% and I'm subtracting off how much they're depreciating by, right? If the butterfly population is growing, I'm going to take that 100% and I'm going to add to it what they're appreciating, what they're growing by. So that's why it's always 1 plus I, because 1 represents 100% of something, meaning not growing nor decaying. But if I add the interest rate, it's growing. If I subtract the interest rate, it's decreasing by that much. So if it was decreasing by 20%, I would actually have 0.8 in this bracket, because I'd have 80% of it left. If it was decreasing by 30%, I'd have 100 minus 30, so I'd have 70% left of the original population, right? So that's why this, if the value in this bracket is between 0 and 1, it's decreasing, correct? Because it's how much is left. You don't have 100% left, you have 90% or 70% or 60% or 20% left. So that would mean decreasing. So if this value here, this base value, is between 0 and 1, then it's decreasing. If this base value is greater than 1, it's increasing because it's more than 100%. Does that make sense? Ish? Okay. We're going to look at the first one here. It says the initial price of a car is $30,000. I actually love these because as long as you know what formula you're filling it in, you need to know, have one missing known, right? It's just like in physics equations, or you just, literally if you're missing one thing. If you're missing more than one thing, you got problems. Go back, try again. So the initial price of the car is $30,000. So I go I equals 30,000. That's why I like my advanced atmospheric analysis class, because it was literally just formulas and numbers. And you had to find all the numbers but one and solve for that missing one. It was the greatest day, I think. If the value of the car depreciates means I'm using F equals I, my original, and I'm taking my 100% and I'm subtracting the interest rate from it because it's depreciating to the number of years. So I know I have that formula by the depreciate part, and it depreciates by 20% per year, so that's little I, but I don't use 20, I use 0.20. I want to take that 20% and divide it by 100 to get rid of the percentage sign, right? Because there's no spot for percents in this formula. So it depreciates by 20% per year. So how much is left? If it's depreciating by 20%, how much is left? 80%. That's why this is going to become 0.80, right? Once we fill it in. If the car is new in 2005, how much will it be worth in 2010? What are they giving me there? Number of years, how much is it? 5. Okay, let's solve for it. So we're going to get final, is what they're asking us to find. If you don't know, it's missing one, so that would give it away. Equals 30,000, bracket 1 minus 0.20 to the 5. Now, oh, it's switching. It didn't say critical.
It's in red. It's in red.
That's an assumption. All right.
What?
Nothing. He's not going to repeat himself because we're quick. Yes?
Why is it 5 years, not 6?
Because it was new in 2005. They want to know what it's new in 2010, which is
But
5
wouldn't
years.
you count 2005 when you're counting?
No. It's not depreciating that year. It's depreciating the next year. So geometric sequences of grade 11 is going to rook you. Because in geometric sequences of grade 11, they have used n minus 1. So it's the same formula, but they use n minus 1, so they include the initial year. We don't. That's grade 12 is way better. You just subtract the 2 years from each other, and poof, you have n. Last year, you had to subtract and add 1 every single time.
I used to use that formula. I use this.
Rebel without a cause. As with Peter. You're not allowed to talk anymore, though. Your talking stick was taken. Remember?
Oh, sorry. I think you're thinking of me.
No, his.
So, if I type this into my calculator, will it do it correctly? If I type it all in at once?
Probably.
Yes, because you know that what's the only thing your calculator for sure will do? Dead mass. And so it will do the exponent first, then multiply. So it will do it. Your calculator has bed mass rules. So people will say to me, what mode do I need to be in? Bed mass mode. You need to be in whatever mode you're in. It doesn't matter, because the only time the mode matters is if I'm pressing sine, cos, or tan, or second sine, second cos, second tan, which I'm not. So in 5 years, it would be worth $9,830.40. And if this was the diploma, you would write a sentence. You would say, the car would be worth, in 2010, the car would be worth $9,830.40.
Okay, so our diploma, there's also choice response.
And numeric. Yeah. You have 3 written. One's worth 2, each written has 2 parts, one's worth 3 marks, one's worth 2. So it's out of 15, the written. Okay, here it says, how long will it take? So it's making me find n. To the nearest tenth of a year matters. How many zeros are in 10? 1. So how many decimal places in the 10th? 1. He made it. For the car to be worth half its original. So what did it give me? It's still depreciating at 20%. The initial didn't change. What did it give me this time, though?
Final value.
What is it?
15,000.
Yep, I agree. So we're going to go 15,000, which is the final, equals initial, which is 30. 1 minus 0.20 to the end. Now, guys, paying attention, if you do this next step every single time, I promise you'll get this answer right every single time. Always, 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 whether we're going to use our calculator or solve it algebraically, you should do the next step every single time. Divide the 30,000 over. The reason why is people will try and go 30,000 times 0.8 to the end. You can't do that. This 0.8 to the end can only join another 0.8 to the something. You can only put together bases that are the same. This 30,000 can never go in there. If you ever do that, you're going to be wrong. So I try and get rid of that issue right off the bat. So I'm going to divide it over immediately. So if I have my final and my initial, the very first step I'm going to do is divide over my initial. So I'm going to get 0.5 equals 0.8 to the end. And because you guys are all genius level, every single one of you, I'm going to show you how we can do it with our calculator, but I'm also going to show you how we can do it algebraically. And it is not log base 10 volts. We could do that, but we're going to convert.
What Mr. Smith said.
You can totally log base 10 both sides
This is what he actually like showed the logs in this like.
in exponentials. Yeah. So
I don't.
we're going to type this into y1 and y2. Everyone's going to do that right now. y1, y2, we're going to find the intersection. That's going to be our first way of finding it, is algebraically. Or not algebraically, graphically. The opposite of algebraically, which is graphically. So in y1, we're going to have 0.5. And the reason why we divide this over, guys, if we don't divide this over, my y max has to be bigger than 15,000. If we divide it over, a general window might work. So we need to divide it over. So we go 0.5 into our y1, and then 0.8 to the x into our y2. That is it. And we go zoom 6. Just your normal standard window should work. If you can't find it, often the problem is your x max needs to be bigger. Like it might be at more than 10 years, or it might be 20 or 30, right? So just make your x max bigger. That doesn't mean you have to make everything 10,000. Please don't be that person. That is not helpful. Often your calculator revolts against you when you do it. So we go second trace 5, enter, 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 because we're finding where they intersect. Whenever we do y1, y2, we find out where they intersect. We get n equals 3.1 years. But we're going to do it algebraically as well. So, what? No, do not log the answer. Okay. So algebraically, because Peter really wants to log base 10 both sides, we'll go that route. Sure. We'll go log base 10 of 0.5. If ever you can't solve by common base, which we can't solve by common base, 0.5 and 0.8 can't be made the same base. If you can't solve by common base, you're going to log both sides. So you're going to go log base 10 of 0.5 equals log base 10. Peter's been living for this moment, so I have to bring it. 0.80 to the n. Now, if you don't understand what I'm doing, chillax. You're literally just log base 10ing both sides. You're like, what is the log? I don't even care right now. Just log base 10 both sides. So if we ever have an exponential function and we can't solve by common base, which we did on Friday, right? We can just log base 10 both sides. Okay? There's a rule over here. I'm going to show it to you early. The rule states, it's a power rule. The rule states here, log base b of m to the n. If I have a log with a base and then something beside it, I can actually take the exponent and I can drop it in front. Do you see it here? So if you have an exponent on a log, you can actually drop it in front. And that would be our next step, because we need that n to come down, because I don't know how to solve for that. So based on power rule, this n can actually drop in front. So we're going to get log base 10, and the base 10 is kind of comical. I'll show you why it's comical. Equals n log base 10 of 0.80. Now, if I want to get n by itself, what am I going to do?
Divide both sides by log 10.
Divide by log base 10. You can just set it on my chair. Divide both sides by log base 10, 0.8. The reason why I say log base 10 is kind of comical is because the log button is log base 10. So I'm writing this log base 10 for no reason. I could just write log. So whenever there's a log without a base, it is base 10. So how could I write this? I could have just wrote it as n equals log 0.5 divided by log 0.8. Because base 10 logs are just the log. So if I have a log that's any other base than 10, I actually have to do more steps, right? But if it's log base 10, it is just the log button. So go to your calculator and type in log 0.5, close the bracket, divided by log 0.8. And what do we get? 3.1 years. So same answer. How you can do it algebraically without even knowing how to do logs. Okay? So all the common base stuff yesterday or on Friday, all that common base stuff, we could technically log base 10 both sides, but there is so much math you would have to do to get your logs to separate and then pull stuff. Don't ever do that. If it's like this massive, like this to the power of this times this to the power of this divided by this to the power of this equals this to the power of this times this to the power of this divided by this to the power of this, I promise you it is a common base question. Because if you have to log base 10 both sides of that thing, you're going to get 6 logs, and then you're going to have to expand the logs, drop it. Oh my gosh. No thank you. So if it's big like that, it is a common base question like we did on the Friday. Okay? Okay, let's try this one. Example 2. The population of the city was 250,000 on January 1st. Now you have to read because you have to make sure that if that's final or initial by keeping on reading, right? We don't know if it's final or initial till we keep going. The population of a city was 250,000. Thanks, board. I appreciate you. Not. Was 250,000 on January 1st, 2000. And then it was 310 on January 1st, 2008. So which one is my initial? 250,000 because it happened first, right? And what's my final? 310. Am I appreciating or depreciating? Appreciating. So populations fall under this too, appreciation, depreciation. If the growth of the rate of the city can be modeled by exponential growth function, the average annual growth rate, what are they making me find? Little I. Of the population of the city to the nearest 0.1%. Okay, I'm missing N. I'm in trouble. Am I in trouble? What's N? 8. And it's because they did January 1st both times, right? If they did like July 1st or something like that, it'd be 8.5. You have to watch yourself on what the dates they give.
Would they ever give us a question where it's like starting on January 1st and ending on like May
I hope
the
not.
15th?
I really hope not. Have you ever seen it? I hope not. But,
No exponents?
yeah. Okay, so here we have, guys, we only have to log base 10 both sides. Everyone paying attention, listening, looking at me? We don't, look at me, here, come to me. I feel like I'm playing Roblox with my daughter. She's always like, Mom, I'm over here, come to me, because I get lost. I cannot move things. It's brutal. Okay, it's legit. I suck. But anyways, nonetheless.
We friends you on Roblox.
No. I do not frequent Roblox, but just when my children ask me. Okay, so, paying attention. You only log base 10 both sides when you're missing the exponent, when you're missing n. Because the reason why you log base 10 is to get that n to drop in front and not be an exponent anymore. Because it's really hard to solve as an exponent, correct? But if I drop it in front, it's really easy. I divide. So the only time you have to log base 10 both sides is if you're missing the exponent. Other than that, just do math that you've learned throughout your whole lives. Okay? So we have final, which is 310, equals initial, which is 250. If it's growing, your final should be bigger than your initial. We agree? Which also means we need to use 1 plus. So 1 plus I to the 8. So am I missing my exponent? No, I am not log base 10 both sides. That is not helpful in this situation. It is only helpful if I need that n to come down. So I'm going to divide the 250,000 over, and I would do that anyways, no matter what I'm given, because the moment I have final and initial, my very first step better be to divide them over. All these zeros cancel, and I get 31 over 25. Please do not round before your answer. That is illegal in all of the states, territories, provinces, countries, and Mars. Okay.
Alright, let's go to the slide.
So, how do we get rid of an exponent of 8?
Wait, you can't just root 1.24? Because that was all I gave in the calculator.
31 over 25 is.
No, you can put 1.24, because
Oh,
that stops.
yeah.
But if it's a non-terminating, non-repeating decimal, please no. Okay. So, sorry, what were you going to do?
I was just explaining.
Yeah, what were we doing? How do we get rid of the 8? We can 8th root it, or we can raise it to the power of 1 over 8. Yes, because we need it to be a 1. I'm so proud right now. So if we raise this to the power of 1/8, that would do the same as the 8th root. Remember grade 10? We'll bring you back. So if I had the 8th root of 31 over 25, that is the same as 31 over 25 to the 1/8, correct? Square root is 1/2. Cube root is 1/3. So if I want to eighth root something, I could just raise to the power of 1/8. That is the same. Those are the same thing. Interchangeable. Boop, boop. Interchangeable. All right? So, and then we have to go and subtract 1 from it. So I equals 31 over 25, which Chloe said was 1.4 by itself, right, Chloe? Not rounded or anything? And you could use 1.4. There's nothing wrong with that.
Yeah, that's fine.
And then I equals whatever. What does I equal? I'm getting 0.027.
Yeah, I got the same.
Okay.
I'm just trying to mess.
Okay.
Sure.
You know what? You answered 1/8 and made my heart sing. I'll forgive anything. It wants it to the nearest tenth of a percent, so I'd have to times by 100 and get 2.7%. And because it's a word problem, I would write a sentence. I just do not have room. So I would write the average annual growth rate of the population of the city from January 1st, 2000 to January 1st, 2008 is 2.7%. Okay? All right. Yeah, we're not doing the next one anyways, but it would be 4.5%. That's just a typo. Okay, I want you to go here. We're jolting ahead. Half-life doubling, tripling formula. And we're jolting ahead because you're going to do the other ones in between the homework. Okay, so half-life doubling and tripling. If you hear, how do you know? It's like appreciation, depreciation. Well, you know it's appreciation or depreciation if it's not the other two formulas. Okay? So this one is half-life doubling and tripling. It talks about bacteria. It'll be like it doubles or triples in this amount of time. Or it talks about like radioactive material half-lifing, which you hope it does, because if you're drinking some radioactive material, you hope you're not walking around just holding on to some radioactive stuff. Hopefully it depletes really quickly. Hopefully it has a fast half-life, right? So how do you know it's this one? It'll say half-life doubling or tripling, okay? Now, same things happen. So we have final amount. That didn't change. Initial didn't change. Interest rate in decimal form did not change. Oh, it's not. What? This is a typo. This is a typo. This is bad. This is bad. This should be an R. This should be an R. R. And I'll explain why. Because R is actually nice. So if it says doubles, what would R be? Remember, 100% is normal. So if it doubles, what would it become now? 200%. And what's that in decimal form? 2. So that's why R is 2. If it triples, it wouldn't be 100% anymore. It would be what? 300%. So what would R be?
3.
And if it halves, if it's a half-life, it wouldn't be 100 anymore. It would be what? It would be half of 100, which is? You could use a half, or you could use 0.5. Or a half. Both of these are totally fine. Now, it's the T and the P that cut, yep.
Could you technically use this for just any quadruple, quintuple?
Yep, you could. Yep. So, T, this is the hardest part for people. T is time to reach final. Let me write it up here. And P is the period. And the period is how long it takes to repeat itself. We agree? That was in trig. That was the period is. So this one is going to be how long it takes to repeat itself, to double, to triple, to half, right? So if it says it halves every 3 hours, then every 3 hours, if it was 1,000, it's now 500. If it's 500, it's now 250. It's 250, it's 125, right? And so it's going to be the half-life, how long it takes to double, triple. So here we have a lab tech placed a bacterial cell. So my initial is 1 into a vial at 5 a.m. The cell divides in such a way that the number of cells doubles. So what does doubles tell me? R is 2. It doubles every 4 minutes. Is that T or P? P, because the period of doubling is every 4 minutes, right? 4 minutes I double, I double, I double, I double, I double, I double. So if it doubles every 4 minutes, that's a period. That's how often it repeats itself, right? So it's 4 minutes. How long does it take for the cells to divide to produce 4,096 cells? So it gives me a final. What is it looking for? So let's fill it in. We get 4,096 equals my initial, which is 1, bracket 2 to the t over 4. And what I tell you the first step should be always divide the initial over if you have a final and an initial, which does nothing in this case but improving the one. So I could y1, y2 this. If I do, my y1 needs to be bigger than, or my y max needs to be bigger than 4,096, right? Or what could I do? Yeah?
Common base.
Common base. Or Peter would probably want to do what?
Log both sides.
Log both sides. You can do either. The reason why you can log base 10 is because we're looking for an exponent, right? So we drop that t over 4 over, and we have to multiply by 4. But I always look for common base first because it's often easier. 2 to the what is 4,096?
12.
So we get 2 to the 12 equals 2 to the t over 4. And now I can set the exponents equal. 12 equals t over 4 multiplied by 4. And t equals 48. Example 2 is one that often is done terribly because people don't spot the initial or final. They ask me what the initial is. So this one says, what is the half-life? So that's R, which is a half or 0.5, whatever you want to put it as. Of plutonium-232. That is an isotope. Please don't put 232 anywhere in the question. It doesn't tell you, like, it doesn't give you the milligrams of it. That's just an isotope. If you want to, you can go, no, thank you. I don't even care what that is. Like, do not put 232 somewhere in this question. Okay? Okay, what is the half-life if in 204 minutes, did they give me P or T?
T.
T. Because they're asking for the half-life. They're asking for P, right? They're asking for the period of the half-life. And they gave me T as 204 minutes. Well, if I know I'm missing P, I know I have to have the initial and the final, or I cannot solve this. Okay. A sample decayed to 164th of its original. And then people call me over and immediately say, what was the original? It doesn't matter. Whatever you make the original be, the final just has to be 164th of it. Correct? So if I'm allowed to choose, I pick 1. I make my initial be 1. And what's 1/64th of 1? 1/64th. Remember when you use the word of, it's just multiplied? So 1/64th of 1 is 1 times 1/64th, which is 1/64th. Could you have picked 100?
Yes.
Sure. Times it by 1 over 64 and put that as your final. You could have picked 7. I would not suggest it. You'd have 7, like a 7 over 64. Like, it just makes it harder on you. But you could pick whatever you want for your initial. You could pick 1.798. Don't know why you do it, but you could. You just have to times it by 1 over 64 to get your final. Okay. So we have 1 over 64 equals 1 times a half to the 204 over P. The catch is that T and P have to be in the same units. So I know that 204 minutes, so I know P's in minutes. Because they have to be the same units. It's a ratio, right? First thing I do is divide my 1 over, which is good. Oh, why? Pretend it moved. It's not. That is not a square root sign. It's stupid, and I don't know why I did it. But it did. So I get 1 over 64 equals 1/2 to the 204 over P. And what can we do with this one? You can log base 10 both sides, sure. Or common base. Or graph it. If it says algebraically, you cannot graph, but if it doesn't say anything, you can do what you want, right? So here we have 1 over 64 is a half to the what? To the 6, isn't it?
Yep.
And then this is the half. The doubling, tripling, half-life ones sometimes lead to common base because they're nice. Like the first ones will not ever lead to common base, appreciation, depreciation, but these ones often do. So I'm going to get 6 equals 204 over p. And then if I want p by itself, I just swap these two. So I can bring the p up and multiply, bring the 6 down and divide. So I get 204 divided by 6, which is
34.
34 what?
Minutes.
Yeah. And then I would write a sentence, and it would say, the half-life plutonium 232, if a sample decayed from 1/64 of its original value is 34 minutes. Okay, if you look at the next page, there's an example 3 and an example 4 and an example 5. You see those? Those and the ones on the previous page are for homework. We're going to go through the answers at the very beginning of class tomorrow because these ones are better than the textbook ones. Textbook ones sometimes are convoluted. So we're going to do those.